everybody. Check out our new First Principles Guide to Cybersecurity. This guide goes through key CSO Perspectives podcast episodes, discussions, and essays that help you understand the challenges that security teams are faced with every day and will lay out the fundamentals of topics that are universally and continually relevant to ensure that you are situationally aware and prepared for potential cyber events. Let the CyberWire help you along your path of professional development and continuing education on cybersecurity. Download the guide today at thecyberwire.com/firstprinciples.
Welcome to the CyberWire's Research Saturday podcast, brought to you in part by our title sponsor, Collide, endpoint security for teams that Slack. Hello, everyone, and welcome to the CyberWire's Research Saturday. I'm Dave Bittner, and this is our weekly conversation with researchers and analysts tracking down threats and vulnerabilities, solving some of the hard problems of protecting ourselves in a rapidly evolving cyberspace. Thanks for joining us.
So, we do, like a lot of other vendors, we do find lots of new ransomware families, but this one in particular stood out to us for a number of reasons. We thought it seemed to be relatively sophisticated, and so we thought it was something to watch and something we should maybe publish about.
That's Dick O'Brien. He's a principal editor with Symantec's Threat Intelligence Research Team. The research we're discussing today is titled Noberus. Technical analysis shows sophistication of new Rust-based ransomware. And now, a word from our sponsor, Collide. Collide sends employees important, timely, and relevant security recommendations for their Linux, Mac, and Windows devices right inside Slack. Collide is perfect for organizations that care deeply about compliance and security, but don't want to get there by locking down devices to the point where they become unusable. Instead of frustrating your employees, Collide educates them about security and device management while directing them to fix important problems. Visit collide.com/TCW to sign up today. That's KOLIDE.com/TCW. And we thank Collide for sponsoring our show. We would also like to thank SpyCloud for their sponsorship. Stolen data circulating on the criminal underground is fuel for data breaches, account takeover, ransomware attacks, and online fraud. Your biggest security risk might be a breach or malware infection outside of your control that leaks the data of your users. SpyCloud constantly recaptures and analyzes new data from the criminal underground, powering solutions that proactively protect over 2 billion employees and consumers worldwide. Learn how to make recaptured data your best defense at spycloud.com/cyberwire. That's spycloud.com/cyberwire. Well, the information that you published here is in two parts, and you start off here going through the anatomy of a specific attack. It's quite an interesting narrative here. Can we walk through it together? What exactly happened to the organization that found themselves the target of this group?
Yeah, it's an interesting attack in terms of, it demonstrates that whoever was behind it, now we don't know whether it was the ransomware authors themselves or an affiliate, really knew their way around a network and knew how to deploy this ransomware. And also they were, quite confident in themselves because in this case, the organization seemed to have discovered the attack and made efforts to kick them off the network. And they came back with another strain of the ransomware and managed to succeed. And usually when an attack is discovered, that's it. The attackers disappear and they try something else. So how they got onto the network is a little bit unclear. We saw the first signs of suspicious activity seem to date from November 3rd. And it seemed to kind of come from a remote machine on the network. So It could be a case of it was a machine that we didn't ourselves have visibility on because maybe our software wasn't running on it, or else that the attackers may have compromised or they may have added a new machine to the domain and then used that to start the attack.
And so once they were in the network, how did they go about spreading around and also maintaining persistence?
They used a lot of the tools and techniques that we'd see targeted ransomware attackers used. There's a number of steps that they all need to take. It would, escalating privileges in order to gain admin privileges, stealing credentials, and then moving laterally across the network. One of the steps that we saw them take was they managed to disable a remote admin feature, and that effectively took away the safeguards against pass-the-hash attacks. They also used PowerShell via PSExec, disable Windows Defender. And they didn't disable it as such, they just modified it in a way that it was disabled so that they added executable files to the exclusion list. And then used PSExec again to deploy the ransomware across the network.
At what point did the targeted organization detect that something was going on?
I believe it was during the ransomware deployment stage. And the reason I say this is because they had to recompile a new version of the ransomware. So it was obviously once they started rolling out the ransomware itself that they noticed that it was the attack was underway. The ransomware itself kind of does a fair bit of work. So there may have been a kind of window for the organization to notice the attack and close it down before the ransomware could finish doing its work.
Is there any sense for how long they were in the network before they actually started encrypting files?
Yeah, I mean, let me see, the first time we were sure of malicious activity was November 3rd, and the actual encryption, I believe, occurred on November 18th. So nearly 2 weeks, which is, a long time to be on a network. And, we might get to it later, but they made the most of that time on the network because they seem to have done pretty extensive reconnaissance. They knew an awful lot about the organization they were attacking.
Well, let's dig into that. How were they going about that reconnaissance and what sort of information were they gathering?
Obviously, I mean, we don't have visibility into every single thing that they did, but when we analyzed the ransomware sample that was used against the victim, it had a number of interesting features, and that not only were administrative credentials for that organization baked into the sample, but it also had an application kill list. Now, an application kill list is not unusual. This is a list of applications that they want to shut down before encryption launches. But it seemed to be unique to that organization. So they had gone about and they realized what applications were running in that environment, and they added it to the kill list. So the ransomware was kind of highly tailored to the victim.
Well, let's dig into some of the technical details of this particular ransomware operator. One of the things that you all noted was that they were doing their development in Rust?
Yeah. I mean, that's one of the things that caught our attention. I gather Rust is a really hot programming language right now. It's quite popular. I think one of the reasons it's quite popular is that people believe that it can be used to create kind of quite clean, efficient applications. And I guess there is an obvious appeal to ransomware operators with that because speed is of the essence in ransomware attacks. As I mentioned earlier, the average piece of ransomware has a lot of work to do. It has to try and delete the backups. It might have to exfiltrate data, and then it has to encrypt a whole bunch of files on each computer. So it's quite labor intensive. And I guess the quicker it can accomplish those tasks, the better. And maybe the ransomware developer, I guess, like any other software developer, said, well, let's see what Rust has to offer and whether it gives us any advantages.
Yeah, I guess not surprising that they would be using the latest, greatest hot tools.
Yeah, I mean, ransomware is very much a marketplace like anything else. And you see people try to experiment with new techniques and new technologies.
Well, let's walk through the technical details together. The information that you all published has a an extensive step-by-step description here. Can you take us through what exactly happens here?
Yeah, I mean, it does a lot of things before it starts encrypting. As I mentioned earlier, it removes the shadow copies, and then it issues a command to collect a universal identifier from the infected machine. And that's something we can maybe talk a little bit more about later, because I think it's one of the more interesting features of this ransomware. It then attempts to mount hidden partitions, and then it also then attempts to propagate itself via network shares, and it looks for available shares by using the netuse command. And then it also, the aforementioned administrative credentials that is baked into the ransomware are maybe leveraged then to use to propagate via network shares. The next step it takes is to kill processes on the machine. There's a kind of a generic list of processes that it will try and kill, but it will also, as I mentioned earlier, kill a custom list that are specific to that organization. Then it begins encryption. Like most ransomware, it doesn't try and encrypt everything on the hard drive. It excludes certain directories and file names. And that's really just to kind of speed up the encryption process to make sure that they're just encrypting valuable data as opposed to, stuff that the user doesn't really care about.
You mentioned it was interesting the way it was working with UUIDs. What caught your eye there?
Yes, this was quite an interesting feature because it has it has a unique ID for each infection, and this creates an access token that creates a unique address for the victim to visit in order to negotiate with the attackers or pay the ransom. And this is something I haven't seen before anyway. I'm not saying for sure that nobody else has done it, but it's certainly something unique that we've seen. That it means that only somebody with access to the infected computer can get the address to visit to negotiate with the attackers. And we think that this has been caused by the fact that there's been some level of frustration expressed by ransomware attackers in recent times that outsiders, neither the victim or their representative, are kind of crashing these ransomware negotiations and disrupting them. And it could be reporters, indeed, looking in on ransomware negotiations and reporting on them. And what usually happens is that somebody might upload a sample of the ransomware to VirusTotal or something like that, and the Tor site that's used for negotiation is in that sample. And then it becomes public information, and anybody who has the address can visit it. So this kind of creates an address that is unique to the victim and is only accessible to the victim as well. But yeah, there's a little bit of an innovation. It also suggests that people who developed this ransomware knew what they were doing and are maybe kind of experienced operators in the space, knew that this was a problem to be addressed, and this was their way of dealing with it.
Do you have any indications of who might be behind this?
No, not in terms of identities. We have been informed by third parties that it has been advertised on Russian-speaking cybercrime forums. So there's some suggestion there that the authors are Russian-speaking, but that's not hard and fast evidence or anything like that. But the fact that, it's being advertised in the cybercrime community, and the fact that there's a fair bit of sophistication behind it, I'd say, it isn't these people's first rodeo, so to speak.
Yeah, I think that's an interesting aspect to this. I mean, it sounds to me like this particular group is on the higher level of sophistication in your estimation?
Definitely so. I think it's one to watch. Now, whether they gain traction or not, or is another question. There's a number of factors I believe that would kind of decree the success of ransomware. But if you're looking at up and coming ransomware families, this is one I would definitely be watching in the coming months.
Are there any specific recommendations here based on the information you gathered for organizations to best protect themselves against this group?
I think advice with regard to Noberus would be kind of the same with regard to all of the other, high-level ransomware threats, and that is that you need to adopt defense in depth, because you can't rely on any single strategy, because these guys are, it's human-operated ransomware. They, if they find themselves stymied at one point, they will usually attempt a different tactic. So you really need to kind of consider your protection across the attack chain. In terms of vectors, how they get onto networks, I would say that a lot of the more frequently seen threats we've seen are being spread in collaboration with botnets. TrickBot, Emotet is back again, is also being involved in ransomware, ICID. Botnets like that, they have kind of the reach to get into organizations. They're able to, they have a high level of spamming infrastructure behind them. And what they seem to do is they now have a close relationship with ransomware organizations, and they sell off the choicest victims to ransomware attackers, who then kind of proceed to elaborate, to unfurl the attack further. So that's one major infection vector. The other one we've seen a lot of is exploitation of vulnerabilities in public-facing applications. It's not done by all ransomware groups, but a select few seem to specialize in it. That's your point of entry. Then once they're on the network, I think I would advise any organization to kind of familiarize themselves with the techniques that ransomware groups use to steal credentials, to move across the network, and escalate privileges. So you will see the use of some malicious tools, but there's an awful lot of living off the land type activity, or abuse of legitimate tools. We've seen an awful lot of remote access or remote desktop tools being deployed in ransomware attacks, for example. So with that in mind, keep a close eye on what applications are running on your network. And if there's applications that you do not expect to see running on your network, or are not authorized to run on your network, like remote access programs, you need to kick them off immediately. I would advise close monitoring of any PowerShell usage. Also, implement multi-factor authentication for admin privileges and things like that. And then you get onto your security software stage. And I'm not going to give the hard sell on our products. But obviously, a good AV solution, a good EDR solution are critical in terms of being able to identify and remediate ransomware attacks.
Our thanks to Dick O'Brien from Symantec for joining us. The research is titled Noberus. Technical analysis shows sophistication of new Rust-based ransomware. We'll have a link in the show notes. Thanks to Collide for their sponsorship. If you have Slack, Collide is the perfect solution to improve endpoint compliance while educating your employees about device security. Try it out for free at collide.com/TCW. Thanks also to SpyCloud for their sponsorship. Learn more about how SpyCloud transforms recaptured data to protect your business from account takeover, malware, and ransomware at spycloud.com/cyberwire. The CyberWire Research Saturday is proudly produced in Maryland out of the startup studios of Data Tribe, where they're co-building the next generation of cybersecurity teams and technologies. Our amazing CyberWire team is Elliot Peltzman, Trey Hester, Brendan Karp, Eliana White, Paru Prakash, Justin Sabi, Tim Nodar, Joe Kerrigan, Carol Terrio, Ben Yellen, Nick Valecki, Gina Johnson, Bennett Moe, Chris Russell, John Petrick, Jennifer Iben, Rick Howard, Peter Kilpie, and I'm Dave Bittner. Thanks for listening. We'll see you back here next week.